All right, here is how to solve the lunar landing problem. So we've got this lunar lander making a descent to moon base 1. So I'm going to just draw, I don't know, what looks to me like our lunar lander, and it's making its descent. Get out of here. Down. Yep, I'm not great at drawing. Okay, the lander descends slowly over the under the retro thrust of its descent engine. The engine is cut off when the lander is 5 meters above the surface. So this is our initial height of 5. Okay, so I'm going to put that in here. Okay, and has a downward speed of 1.5 meters per second. So that's V naught, initial speed. When the engine is off, the lander is in free fall. What is the speed of the lander just before it touches the surface? So that means that its ending speed, so when it says just before it touches the surface, you'll include, that would be a height or a y of 0. Okay, so final height of 0. All right, so what they're asking us is what is the final speed? And I'm just going to put a little question mark in there. Actually, I'll do that in a different color. But they do tell us that the magnitude of acceleration is 1.6. So I'm going to put a negative because we know that it points downward. So, and you'll see in a second. Okay, so, and we're trying to find speed. Okay, so here's what I'm going to do. Over on the side, we've got our kinematics equations. And what I want you guys, I'm going to walk you through how I figure out which one to use. So I know that I don't have V and I don't have T, but I want to find V. So first of all, V has to be in the equation. And when you look through, we've got V is here, so that works. V is here, so that would work. V is here, that works. And this last one doesn't have a V, so I'm not going to use that one. Then I can't have T in it because I don't know T. So that crosses this one out. That crosses this one out. So this is the formula I need to use. V squared equals V naught squared plus 2a change in x, or we'll call it change in y here. So let's set this up. V squared equals V naught is 1.5 squared plus 2 times negative 1.6. And my change in x, so I'm going to do y, which is 0, minus 5. So that's going to be a negative 5. All right, so I'm going to multiply all this stuff together. I paused myself because I forgot my notes. Okay, so 1.5 squared is 2.25. And then 2 times negative 1.6 times negative 5 gives us 16. So V squared is equal to 18.25. And we need to take the square root of that. So we get that V equals 4.27 meters per second.